So tunicates are an invasive aquatic species which came to PEI waters a little bit over 20 years ago. And since tunicates showed up, they've been causing major problems for our local aquaculture community, and in particular for mussel fishermen. Tunicates release thousands of larvae every year into island waters, and these larvae are sticky. They stick to underwater surfaces, like mussel socks, which you can see in my slide. Now, the effect of this over time is that tunicates engulf the entire surface of a mussel sock, as you can see top left, your top right. Tunicates and mussels eat the same food, and the problem is that tunicates starve mussels when they surround their mussel socks. And the problem with this is, at the best, the mussels take longer to grow, and at worst, a mussel fisherman loses his entire yield for that year and kills every single one of his mussels. Current research is focused on mitigating and containing the tunicates that are in our waterways, but we want to approach that problem differently. To directly address the tunicate problem, we will harvest tunicates industrially, removing large quantities from the water and turning them into valuable products. Now, one of those products is cellulose-based. So nanocrystalline cellulose is simply a component of cellulose. You can break cellulose down into something smaller. You can think about it as a microscopic version of rebar. So cellulose we associate with plants. The floor you're standing on, that I'm standing on, has cellulose in it. Many other plant sources exist. But tunicates are the only animal source of cellulose that is known to science. And because it's synthesized in a tunicate differently than it is in a plant, there is a difference between the nanocrystalline cellulose you can isolate from tunicates versus what you can isolate from plants. If you think about nanocrystalline cellulose as microscopic rebar, then the rebar you can isolate from a plant is about 5 feet long. But what we can get from tunicates is much bigger, about 20 feet long. And if you think about using these in composite materials as a structural reinforcement, like a rebar is in a concrete building, then you can imagine that the applications for tunicate-sourced NCC, nanocrystalline cellulose, are much larger than plant-sourced nanocrystalline cellulose because the material itself is inherently more valuable. It is longer crystals, and we can't get those crystals anywhere else but tunicates. So this research seeks to industrialize the harvesting of tunicates in PEI waters to produce nanocrystalline cellulose of high value, introducing a new product to market which provides an economic incentive to harvest these tunicates in the first place. Now, simply put, it is very difficult to contain and mitigate nature. Our history tells us this in everything we try. But what we've been doing for thousands of years is simply to harvest nature's bounty. We see tunicates as a problem, as a nuisance species, because they're causing us problems. But are they really a nuisance? Are they in fact a resource? Could they be used to produce something valuable, a new industry on Prince Edward Island, and solving the problems that are already associated with our mussel industry because of tunicates? That's the question our research endeavors to address and answer. Thank you.